Advanced level chemistry, organic chemistry. In this video, you are going to be explained the mechanisms of some organic reactions that we met in our A-level chemistry. Mechanism number 1, chlorination of alkanes. I have selected the reaction of methane and chlorine as the example here. Now we can see what happens in this reaction. Cl2 gas reacts with CH4 gas in the presence of sunlight or diffuse light to give CH3Cl or chloromethane and HCl. In addition to chloromethane, dichloromethane, trichloromethane and tetrachloromethane will also be formed in this reaction. In other words, a mixture of CH3Cl, CH2Cl2, CHCl3 and CCl4 is formed during the reaction. So this reaction is not really suitable for preparing specific halogenic alkanes because we get a mixture of products. This reaction is a free radical substitution reaction. Free radical substitution reaction. You can see here there are 4 hydrogen atoms in a CH4 molecule. When CH3Cl or other products are formed, these hydrogen atoms in CH4 are replaced by Cl atoms. That is called substitution. Hydrogen atoms are removed while chlorine atoms are joining. That is substitution. Okay. So this reaction is a free radical substitution reaction. And the reaction of methane and chlorine is a chain reaction that involves a series of reactions or series of steps. Now we are going to see these different steps involved in the mechanism of this reaction. First step, chain initiating step. Now we can see what happens in this step. This is a Cl2 molecule. It has 2 Cl atoms, chlorine atoms, joined by a single covalent bond with 2 bonding electrons. This chlorine molecule can absorb energy from sunlight. After that, this bond between 2 Cl atoms is broken homolytically like this. Homolysis of Cl-Cl bond occurs. It means this bond is broken so that each chlorine atom gets 1 bonding electron. Right. This chlorine atom gets 1 bonding electron. This chlorine atom gets the rest. The electron transfer is shown by this type of curved half arrows. You can use this type of curved half arrows to show the electron transfer. Right. After homolysis of the Cl2 molecule, two chlorine atoms are formed, or two chlorine free radicals are formed. These free radicals are highly reactive. Right, in the first step, we understood that homolysis of Cl2 molecule takes place. As a result, two chlorine free radicals are formed. Now we will move to the next step, chain propagating steps. We can now see what happens here. This is a CH4 molecule. It has 4 CH bonds. A chlorine free radical formed in the previous step attacks this CH4 molecule. As a result, one of these CH bond is broken homolytically, like this. Homolysis of this CH bond takes place, resulting a CH3 free radical, and this Cl free radical joins with this hydrogen atom removed to form HCl. These are the products: methyl free radical and HCl. This methyl free radical formed reacts with a chlorine molecule. Homolysis of chlorine molecule takes place like this, and this methyl free radical joins with a chlorine free radical to form CH3Cl, and another chlorine free radical is also formed. Right, you can clearly understand that in this first step, these free radicals are consumed, while in the second step, these free radicals are regenerated. So you can say that these steps are important for the progression of the reaction. The chlorine free radical can also abstract a hydrogen atom from methyl chloride or chloromethane, forming a substituted methyl free radical CH2Cl. This will react with a chlorine molecule to form dimethyl chloride CH2Cl2. Now we will see how CH2Cl is formed. This is a CH3Cl molecule. It has CH bonds like this. A chlorine free radical formed in the previous step attacks this CH3Cl molecule. As a result, this CH bond is broken homolytically, like this. Homolysis of this CH bond occurs. Right. The result is one CH2Cl free radical, and this hydrogen atom removed joins with this chlorine free radical to form HCl. So these are the products: CH2Cl free radical plus HCl. This CH2Cl free radical formed reacts with another Cl2 molecule, and homolysis of Cl2 molecule occurs like this. This CH2Cl free radical joins with a chlorine free radical formed here to make CH2Cl2, and again chlorine free radical is also formed. Similarly, trichloromethane CHCl3 and tetrachloromethane CCl4 may also be formed as given below. Now we will see how CHCl3 is formed. Right. This is a CH2Cl2 molecule formed. This also has CH bonds. A chlorine free radical attacks one of these CH bonds. As a result, this CH bond is broken homolytically like this. And then what happens? This hydrogen atom removed joins with this chlorine free radical to form HCl. And you can understand that a CHCl2 free radical is also formed. Now these are the products CHCl2 free radical and HCl. This CHCl2 free radical starts to react with a chlorine molecule. Right. Homolysis of this chlorine molecule takes place. A Cl free radical formed here joins with this CHCl2 free radical to form CHCl3, and again a Cl free radical is also formed. Now we are going to see how CCl4 is formed. This is a CHCl3 molecule. It also has a CH bond. What happens is a chlorine free radical formed in the previous step attacks this CHCl3 molecule. As a result, this CH bond is broken homolytically. Right, homolytic cleavage of this bond takes place, and this hydrogen atom combines with this chlorine free radical to form HCl. You can see that a CCl3 free radical is also formed. These are the products CCl3 free radical and HCl. This CCl3 free radical formed reacts with a chlorine molecule. Homolysis of chlorine molecule takes place like this, and this CCl3 free radical combines with a chlorine free radical to form CCl4. Again, a chlorine free radical is also formed. Right. That is what is happening in chain propagating steps. Okay, now we will move on to the third step, that is chain terminating steps. These chain terminating steps are very important for stopping the reaction. Right, these chain terminating steps end the reaction. What happens is two free radicals join together. When two Cl free radicals join together like this, chlorine is formed. When CH3 free radical combines with a CH3 free radical like this, the result is CH3CH3 or C2H6. A methyl free radical can join with a chlorine free radical to form CH3Cl. These are the different steps, different chain terminating steps. These are responsible for ending the reaction. Right, I explained to you the mechanism of chlorination of methane. Homolysis of a chlorine molecule takes place in the first step to make two chlorine free radicals. The second step, chain propagating steps, free radicals are consumed and also again free radicals are regenerated. Okay, and in the third step, joining free radicals takes place. Two free radicals join together to end the whole reaction. Right, we will meet in another video of this type. You may subscribe this channel to see this type of videos.